So if you are good with your triangles and can remember where sine, cosine, and tangent are positive or negative in terms of their quadrants, it's not going to be too bad. There's really, we're solving trig equations, but we're really just using triangles to do it. So we'll start with an easy one. So example 1, if we just said solve for x, and we put sine of x is 1/2, okay? So the first question is, what are we looking for? Don't say x, Mr. Obvious. Be more specific than x. The angles, you're looking for angles, all right? Now, you can go ahead and assume that all your answers will need to be in radians. There won't be any that are in degrees. They'll all be radian. So we'll write and I'll show you how I'll know in a second that it's radians. So, all right, but we can think in degrees and convert to radians if that helps. All right, so we're looking for an angle. Okay, so how are we gonna go about doing this? So it's kind of like, we've got the ratio, we're gonna have to work backwards and figure out sine of what angle gives us 1/2. So now what will be helpful is that little chart, that little ASTC. Why is this going to be helpful? What does it tell us? The quadrants that the trig ratio is positive and the quadrants that the trig ratio is negative. So if we know that we have a positive trig ratio, we know that the angle has to be in which quadrant? 1 or 2. Okay? So now here's how we're going to go about this. The first thing we're going to have to do is we're going to determine which quadrants our angle is in. Okay? So we'll do that first. All right? Second, then we're going to draw the angle in each quadrant. Okay, so I don't know what the angle is, that's what I'm looking for, but I'm going to go ahead and draw it in each quadrant. So we know it's in quadrants 1 and 2 because that's where sine is positive. So our first step is we know that x has to be in quadrant 1, quadrant 2. So I'm going to draw a quadrant 1 angle first, and then I'll go to quadrant 2. Okay. All right. So, all right, now I know it's a quadrant 1 angle. All right, so I've done that. So draw the angle. You know it's in quadrant 1. All right. Now what do we know? If we know sine is 1/2, then what is it that we know? Yeah, you know opposite and hypotenuse, and therefore it tells us the angles, which is what we need. So I'm going to go ahead and make a triangle. So once I draw the angle in the quadrant, I'll make the triangle and label the sides. Because if I already know 2 of the sides, but it's important that I label the sides correctly. Since this is the ratio of sine, 1 is what side? Opposite. 2 is the, so therefore, like what CJ said, this angle has to be 30 degrees, okay? And if it's a 30-degree reference angle in the first quadrant, then the angle is. So my point is, if we're looking for a quadrant 1 angle, and that's the angle right there, what's one of the answers? 30. So the actual reference angle is the answer in quadrant 1. All right, so now we can find the angle by measuring counterclockwise from positive x-axis. So once we determine, we go ahead and we go to the angle counterclockwise from the positive x. So we got one answer is 30. All right, but we said there's got to be 2 locations, right? So now we go to quadrant 2. Now here's the thing, once I know the reference angle, I don't really have to do all that fancy stuff. I mean, I can still make a triangle, I can still do opposite and hypotenuse and all that. But at the end of the day, I know the reference angle is gonna be what? Once you find the reference angle, you've got it, so 30. Okay? All right, but we don't put 30 again. Now we need to, so this is why I put the last part. Find the angle by measuring counterclockwise from the positive x-axis. So if I measure counterclockwise from the positive x, it's this angle, the blue one. So don't put 30 again, because it can't be a 30-degree angle in quadrant 2. It's got to be what? 150. Okay. Now, okay, so there you go. And if this is the question here, solve for x, sine of x is 1/2, and we put those two answers down, it's wrong. Go ahead and put them in radians, still wrong. So here's what we have to understand. You said it, we're looking for an angle. But there's more than that. Those are not the only angles that satisfy the equation. What other angle could work? Right. Anything coterminal with this one, and anything coterminal with this one. How do you say coterminal? You got 390 by doing what? Adding 360. What about subtracting 360? Would that give you an angle? What about adding 360 twice? What about subtracting 360 twice? So what we say is, instead of just doing plus 360 or minus, we say 30 plus 360n, where n is any integer. That gives us all of our coterminal. By writing it like that, that gets all the coterminal angles, every angle that's coterminal with 30. Okay? All right. But that's only one of them. What do I have to do? I got to go to the other one. 150 plus 360n. N is any integer. And it will tell you that. I think they use a K. It doesn't matter. Just use whatever, I think it'll say, I use n. Now, again, all right, so we're gonna have to add that little layer on. Then so if it just says solve, I gotta give all those answers. All right, now, I can tell you this, I've gone through the assignment, they're all in radians. So we might as well just get used to it. So instead of putting 360 in, we're gonna have to put what? 2 pi, okay, we'll get to that. And then instead of 30, what is the radian equivalent for 30? All right, so good. So now let's fix our first answer. So now, for our first answer for this, we'll say x is pi over 6 plus 2 pi n. So we've taken 30 and made it pi over 6. We've taken 360, made it 2 pi. From now on, I'll put our answers in radians. I did it in degrees just to, all right? Now, how do you get 150 in radians? So here's what I would say. If I know 30 degrees is pi over 6, how many 30s are in 150? 5. So since 150 is 5 times 30, therefore it's going to be 5 pi over 6. That's how I would convert it. Doesn't matter, you're going to have to write it. And so we get x equals 5 pi over 6 plus 2 pi n. Okay? All right. Now there's two ways they can ask the problem. One way is just solve for x. Then you know you've got to put your formulas. The other way that they could ask is like this. I'll keep our work here. They could have asked a problem like this. Solve for x such that or maybe they'll put for all answers from 0 to 2 pi, or sine of x equals 1/2. Now, they gave us a boundary. It only wants the answers from 0 to 2 pi. So one revolution counterclockwise. So what do we not need now? Yeah, we don't need the plus 2 pi n, so we would just put our answer, so that you don't have x equals and then have an answer box, right? And you'll just put your pi over 6, and what else would you put? Pi over 6. They'll tell you to separate by commas. Get used to the fraction, get the pi buttons on there, and that's the difference, okay? All right. So we'll do another one here in a second, see if you can get this, and then we'll move on to more difficult, because they're not all going to be this easy. Okay, ready for the next one? So, all right, you got the gist of it. So I'm going to have you do the both ways. I'm going to have you find all solutions and find them from 0 to 2 pi, so you get used to doing the formula. Because I'm going to tell you later on why you're going to need this, why we need that formula. Okay. All right. Can I erase now? Just about. Got it? Yeah. Erase over here. All right. Example 2, given cosine of x equals negative square root of 2 over 2. And A, write a formula for all solutions. So there you go. You know you're going to need your 2 pi n. And then find these solutions from 0 to 2 pi. And then we'll upgrade and make a more difficult problem. What's the other way you can write square root of 2 over 2? 1 over square root of 2, so you might want to write it like that. It's a little bit easier to. Okay, so first step, I would make it negative 1 over square root of 2, so it's a little bit easier to work with. I'm going to ask myself, where is cosine negative? Where would that be?
2 and 3.
2 and 3. We know it's a quadrant 2 angle. It's a quadrant 3. All right, so I'm going to find my reference angle. So let's see, so if I write it like this, what's the negative 1? The adjacent. What's the square root of 2? So what's the reference angle here?
45.
45, okay. So I think it helps to just put them in radians first, and in degrees first, and I would go in radians. Do not put 45 degrees as your answer. 45 degrees is wrong. You got to measure counterclockwise from positive x-axis, so that angle is what?
3 pi over 4.
135, which we'll change that to 3 pi over 4. So I would just memorize that 135 is 3 pi over 4. Okay, rather than having to convert. Your ones that end in 5, 45, 135, 225, and 315 are all something pi over 4. See, this one's 3 pi over 4. So now, what's our other angle? Our other angle is going to be in the third quadrant. We already know the reference angle is what? What's that angle though? That actual angle there is how much? 225, because it's 180 plus 45. And then 225 is 5 pi over 4. So all the pi over 4s are odds. 1 pi, 3 pi, 5 pi, 7 pi. So if you want to know the other two, well, we know basically 45. 45 is pi over 4. You got your 135, 3 pi over 4, 225, 5 pi over 4, and 315, 7 pi over 4. It would be helpful if you just memorize. You don't want to have to go and do all the conversion every time. So now I've got my answers. Pi over 4, I'm sorry, not pi over 4. 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n. There's your two answers. Now, that's the answer to which one? A. If I want the answer to part B, what would it be?
X equals 3 pi over 4.
Yeah. And
5 pi over 4.
5 pi over 4. Okay. All right. So far, so good? All right. Let's look at the next type. This is where it gets a little bit trickier. So you'll have multi-angle, and then we'll go back to, I've got one more type, I just didn't highlight it here. All right. And on this one, we'll do it both ways. We'll write a formula, and then we'll find all the solutions from 0 to 2 pi. So we'll always do those two parts, okay? So what happens if I gave you something like this? Work this one out. Same two questions, but now given sine of 2x equals square root of 3 over 2. Just say that's what we have. All right. It says write a formula for all solutions and find the solutions from 0 to pi. What's different about this problem? It's got 2 in it. Okay? Because now it affects, when we think of angles and plug them in, it affects them. Because it's being multiplied by 2. Because just think, what angle normally, sine of what angle is square root of 3 over 2? What's the easiest one? 60. But you can't plug in a 60. You got to plug in 30. Actually, you can't plug in 60 because you get 120, and sine of 120 is square root of 3. But if we wanted 60 in there, we actually got to plug in 30. So it's a lot to think about. Here's how we do it, okay? If you have something other than just x, we're going to replace it. And we're going to just pretend that it's one angle, and then I'll show you how we'll know what x needs to be. So the first thing I need to do, so this is solving multi-angle. I'm going to let the inside equal alpha. So I'm going to call 2x as alpha. So I'm going to pretend that my problem is sine of alpha equals square root of 3 over 2, and I'm going to work it like I normally would work it for alpha. So whatever the inside, trust me, they're going to make the inside nasty. Just go and replace the inside with alpha. We'll do one in a second that's like 3x over 2 or something like that. So the first thing I'll do is I'll replace it and call it alpha. All right, and now I'll work it, from here I'll work the problem like I normally would. So now we'll figure out, all right, so what quadrants would your answer be in? 1 and 2. Okay, so go ahead and write your formula out for alpha and leave it, and then we'll adjust, and I'll show you how we get all the solutions. On these multi-angles, first write a formula for alpha. So we said quadrants 1 and 2 is correct. All right, what's your angle there? 60. All right, so that's 60. And this one is also going to be 60. All right, so what angle is that in radians? Pi over 3. So we get alpha equals pi over 3 plus 2 pi n. That's one of ours, because for this one. Okay. The other angle is 120. So what's 120 in radians? Yeah, so look, 120, I always do this. It's 60, it's 260 degrees, all right? And we already know 60 is pi over 3. We should have that memorized, so 2 pi over 3. So that's how I convert. So I got it memorized at 30, it's pi over 6, 60, it's pi over 3. Okay? So for the other answer, we got 2 pi over 3 plus 2 pi n. Why am I putting the plus 2 pi n on the end? Yeah, we're all possible. So, but we're not done. So here's where the multi-angle are tricky. It didn't say solve for alpha, it said solve for what? Solve for x. It said solve for x. It's a 2x on the inside, but we gotta figure out what x's need to be. So here's what you do. So you replace the inside with, call it some other angle. You could have called it theta. I call it alpha, and I solve it like this. So you get here, and now you solve for alpha. But we need to solve for x. The problem is solving for x, not for alpha. So what I do next is I'm just going to replace alpha with what? 2x, and I'll solve for x. I'll just go through and divide by 2. So now after I solve for alpha, I'll replace alpha with 2x. So I get 2x equals pi over 3 plus 2 pi n, and 2x equals 2 pi over 3 plus 2 pi n. Well, I still haven't solved for x. I've only replaced it. So we replace it with alpha. Now we've solved for alpha. We went and did that. Now we put our 2x back in. But if I want to solve for x, what do I need to do to this equation? You're going to divide it all by 2. So divide the top equation all by 2. Divide the bottom equation by 2. And simplify. If you don't simplify your answers, you're going to get the red x. So if you can reduce it, you need to reduce it, if it will, okay? And then I'll show you where this formula is helpful. Okay. So if I divide everything by 2, let's see what we get. X equals, what does the first equation become? Pi over 6 plus pi n. So you got to make that a plus pi n, all right? Then x equals, now look, on the second equation, when I divide by 2, you need to cancel these 2. So the 2's cancel, you get what? Pi over 3 plus pi. Now, that is the answer to part A. Okay, so I had to do an extra layer. So look, I first solve for alpha. I did that first, see? First, solve for alpha. I did this first. Second, what do? Replace alpha with 2x, did that, and then I just isolated my x there, and I get a formula. Okay. Now, this only is the answer to part A. Write a formula for all solutions. We've done that. So remember, here's the other way to look at this. Here's what's happening. If you look at this as a graph, when you put a 2 in front of the x, if we go 0 to 2 pi, what it does is it gives you 2 cycles from 0 to 2 pi. If you look at square root of 3 over 2, square root of 3 over 2 is like a horizontal line here. So you can see from 0 to 2 pi, there's 4 places that that graph sine of 2x intersects with the line square root of 3 over 2. Because now when we get to the second part, there should be 4 answers, not 2. And this is where the formula helps you get your 4 answers. This is why you need these formulas. So I'm going to show you how it works here. So now we'll use this to get the answers to part B. It says find all the solutions from 0 to 2 pi. So here's what we do. First, we'll start by doing n is 0. We plug a 0 in for n. We plug a 0 in for n, we get x is pi over 6, and we just do each one, and we get x is pi over 3. I got that because when I plug a 0 in, this disappears and I just get the angles. Then I'm going to plug in a 1 for n. Those are integers, 0, 1, 2. You're going to keep plugging in. I'll show you, you'll know when to stop. Okay? So I'll plug in a 1 for n. I get pi over 6 plus pi times 1, which is pi over 6 plus pi. So now you're going to have to do a little math. You're going to add pi over 6 to pi. Get your common denominator and add it and see what you get. Then I plug it into the other formula, pi over 3 plus pi times 1. Okay? So again, I'm plugging in for n into the formula, 0, 1, because those are integers. It's going to help me get all my solutions. Then I'll show you you'll know when to stop. Okay, so get these 2 answers. What do we get there? Common denominator, what is it? 6 pi over 6. Come on, guys. It's going to have to be faster. So you get 7 pi over 6. Here, pi over 3 plus pi is the same as saying pi over 3 plus 3 pi over 3. We get 4 pi over 3. All right, so right now, 1, 2, 3, 4 answers. Those are the 4 solutions. Now, how do I know to stop? So watch. What would be the next integer? 0, 1, what would be the next one to plug in? 2. But now I know to stop because look, if I plug it into the formula, it's pi over 6 plus pi times 2, which is pi over 6 plus 2 pi. Notice it says from 0 to 2 pi, don't go past 2 pi. So if I do pi over 6 plus 2 pi, that's bigger than 2 pi. I stop. I know, don't do that because I'm going to get an answer bigger than 2 pi. Your answers have to be less than 2 pi. So now you're going to need the formula. It's going to be helpful. You're going to need it. Okay? All right. You try this one on your own. Let's do cosine of 2 more. All right. Same thing. Find the formula. Find solutions from 0 to 2 pi. So it's solve for x. All right, now, time out. What looks a little off about this? Yeah, so what should you do before you even get started? Yeah, just divide by 2. Just make it cosine of 4x equals negative square root. Now you go work. You're not going to solve for 4x first. You're going to solve for what? You're going to pretend the whole inside is what? Alpha. So solve for alpha. Get your 2 formula. Let's see if you can do it. Okay. Let me catch up to you. Cosine is negative where?
2 and 3.
2 and 3. All right. You know adjacent's negative square root 3, hypotenuse is 2, so the opposite has to be 1. So what's your reference angle? 30. So what angle is that right there? What's that? Yeah, but in radians. So your first angle should be 5 pi over 6. I'm going to put plus 2 pi n. Okay? This is 150. We did this one earlier. All right? And then I know the reference angle is the same here, 30. So in this third quadrant, what angle is that? 210. And then do you know what 210 is in radians? All right, how'd you get that so fast? When,
Yeah, just like it was.
how about, well, yeah, I was just thinking 7 times 30 degrees, right?
Yeah.
And then 30 is pi over 6. So you get 7 pi over 6 plus 2 pi. All right? Don't stop there. That's not the answer. So I'm going to take alpha out and put what in? 4x, and then I'm going to divide everything by 4. So I'm going to go ahead and do that now. Replace my alpha with 4x, and then you're going to divide everything by 4. So you're going to need to simplify each fraction, okay? So we get x equals 5 pi over, if you divide by 4, so look, dividing by 4 is the same as multiplying by a fourth. That's how I would work it. So it's going to be 5 pi over what? 24. What's 2 pi n over 4? Pi n over 2. Pi over 2n, however you want to look at it. Pi over 2n. All right? And then on the next one, divide everything by 4. And we get 7 pi over 24 plus pi over 2n. All right. Now that is the formula. All right. Most of your answers are going to be part B. It's just going to say find the solutions from 0 to 2 pi. Always start by plugging in what for n first? 0. Then you plug in what?
1.
Then you plug in,
2.
and you keep plugging in until when? If once you go past a number bigger than 2 pi, you stop. You don't plug it. So I'll just kind of categorize it here. So I'll put n as 0. Well, n as 0 is easy. I can just picture that. If I plug in a 0 for n, I just lose the pi over 2. So I get 5 pi over 24 and 7 pi over 24, right? Because those parts go. Now what might be helpful is you go ahead and get you a common denominator or something. Think about it. So now I'll plug in a 1. You don't write this. You're just going to have to write all the, in that box, you're just going to have to put all these angles. So then I'll plug in a 1. So when I plug in a 1, when I do n as 1, it's going to be 5 pi over 24 plus pi over 2. Well, I might as well go ahead and get common denominator for pi over 2. I'm going to make pi over 2 what? Yes, so I'm going to go and just remember it's 12 pi over 24. So 5 pi over 24 plus 12 pi over 24. So if I'm adding pi over 2, it's adding 12 pi over 24. Okay. Let's see, what do we get there? 5 pi over 24 and 12 pi over 24 is what? 17 pi over 24. Again, look at this ratio. If it's smaller than 2, it's smaller than 2 pi. You know you keep it. All right, and the next one. 7 pi over 24, if I plug in a 1, 7 pi over 24 plus pi over 2, which is the same as saying 12 pi over 24, and we get what? Pi over 24. All right, there's that one. I'm collecting my answers. Look at the ratio. 19 over 24 is smaller than 2 pi. So I got to plug in. So I did n as 0. I did n as 1. Now I do n as 2. I'm running out of room here. So it's going to be 5 pi over 24 plus what? Or, yeah. Plus, when I plug in the 2, it's just plus pi, which we're going to make that 24 pi over 24. So what do you get there? 29 pi over 24. Good. And then 7 pi over 24 plus pi. Again, I'm just using my formula. Why am I getting pi? Because I'm plugging in a 2 for n. But those 2's cancel, and we get
31 pi over 24.
All right, 31 pi over 24. All right. So look, how do you know that you keep that? 31 over 24. Is that less than 2? Yes. It'd have to be 48 over 24 to be 2 pi. All right. Now what?
38 for
Plug in a 3, let's see. So I'll run out of filming area here, so I just have to go over here, and it's 3. So it's gonna be 5 pi over 24 plus 3 pi over 2. Let's see what happens. So go ahead and get your common denominator of 24. So when I do that, I'm plugging in n is 3 into that, so that's 5 pi over 24 plus, if I do a 12 again, 36 pi over 24. And I got 41 pi over 24. Do I keep that? Yeah. All right. And the last one, 7 pi over 24 plus 3 pi over 2. So again, I'm using my second formula, and you should get 43 pi over 24. And I know to stop. How do I know to stop? Why not do a 4? Yeah, that's 2 pi. You're at, now you're going past it. Okay. All right. The multi-angle are a pain. So we'll take a break for multi-angle. I'll come back to one at the end. I'm going to show you the last type of problem. Okay. The last, what's the last expectation to do? How do you work these? And then we'll go ahead, and these, the nice thing about these are not multi-angle. But once you get the answers, you're good. All right, let's say we have this problem here. Solve for x, just 0 to 2 pi, which is nice, but you'll see the problem is not very attractive, but it's not that. Part A, tan squared times cosine equals tan squared x. Don't panic on these, they're not that bad. Part B, tangent x plus 1 sine x minus 1 equals 0. Okay, so both of these are worked in the same way, all right? So when you look at this, we're going to take the same approach that we would take in polynomials. The second problem is actually really what we want. We want a multiplication and we want it equal to 0. What do you call a problem when you have two parts like this multiplied equal to 0? This problem has been what? We didn't do it, but it's been factored. Now you know that each factor you can set it equal to 0. So the idea is this: we want a simple trig equation. And the way we're going to get simple trig equations is if we move everything to one side and try to factor or use identities, if we can set it equal to 0, we can get simple equations. So what I'm going to do on the first one is I'm going to move my tangent squared over, and you'll see that will set me up for factoring so I can get some simple equations. So on the first problem, I moved the tangent squared over. Now when I look at this equation, I can see that in both terms I have a tan squared x, and I can factor that out. So don't worry about the squared right now, it's not going to matter. So what I'll do is I'll factor, and if we factor out a tangent squared, it leaves you with what? Something else. Cosine x minus what? 1. And now what you've got is you have two simple, we're going to make two equations now. So we're going to use factoring, move everything to one side and use factoring to help us. All right, so let's see. I can set, now at this point, I can set tan squared equal to 0. I can set cosine x minus 1 equal to 0. All right. All right, so let's think about the first one. Well, you can do square root, it doesn't matter. Tangent squared is 0, so even if I do square root, I still get tangent x must equal to 0. So I would encourage you just to use square root. So how do we solve this? So now we gotta think. Anytime you get 0, 1, or -1, especially on sines and cosines, you can't use triangles anymore. There's no triangle with a ratio of 0. What do you gotta use? Unit circle. These problems you must use unit circle. So you gotta ask yourself, well, when is tangent 0? At what angle? Let me use the unit circle. Well, all I know are these points, 1, 0, 0, 1, -1, 0, 0, -1. That still doesn't help me know when is tangent 0. Well, I know tangent is what over what? Sine over cosine. I'm not using triangles, I'm using unit circles. So see, because triangle won't help me because it's 0. So I'm gonna make it sine over cosine. All right, so now the only way that we can get the answer 0 is if the top is 0. So now, at what angles is sine 0?
0, 1, 0, -1.
What angle is that?
90.
No.
0.
Where is sine 0? Sine is the y, not the x. Where is sine 0? So look, so you're gonna ask, you're trying to figure out at what angle am I gonna get the answer 0? Well, the only way I'm gonna get the answer 0 for whatever angle, remember, whatever angle I plug in, it's always y over x for tangent. You said opposite over adjacent, y over x, right? Well, I need the y to be 0. That's the only way I can get the answer 0. So at 0 and at pi. That's the solution to this one. 0, pi. There's those two. All right. Try again on this one. So here we're going to make it cosine x is 1. Again, use your unit circle. At what angle is cosine of what angle is 1?
0.
0. So you don't duplicate your answer. So once you get 0, you don't need to do it again. You just put 0 and pi as your answers. Okay? All right. So you try part B. Notice it's already factored. I will give you a hint. One of these you need unit circle. One of these you need triangles. Because you're going to have two problems, right? You have this one and this one. One is you need triangle, one you need unit circle. Okay? So if you can solve that. And this will get you going. We'll finish this. What I can do is if you don't finish it Wednesday with you, we'll finish it Friday. Okay. Or I'll send you the video Thursday. Just remember what we've done today. You're doing part B. Tangent x plus 1 times sine x minus 1 is 0. It's already factored, so I know I can say tan x plus 1 is 0. I'm going to say sine x minus 1. I'm going to solve each of those. Get all my answers. You put your answers in what? Radians. All right. Which one do you need triangles for? tangent. And then use your all students take calculus. You don't need to write formulas because it's not multi-angle, and you just need to collect the answers. So on this one, we get tangent x is -1. Then we got to go through that. All students take calculus. So where's tangent negative?
2 and 4.
2 and 4. All right. So if we're going quadrant 2, let's see. We know that the opposite and adjacent have to be -1. So 1 and -1. I don't have to keep labeling. I just need to know what the reference angle is. So what's the reference angle? 45. So that's it. What angle is that? 135, which is, so you put 3/4. Very good. Then here you know it's 45, so that's the angle, which is how much? Which is 7/4. Remember to memorize. Pi, 3 pi, 5 pi, 7/4. It's the easiest way. All right, there's 2 answers. All right, got 2, so we saved it. Okay. Now here, sine of x is 1. What do I need to do this one? Unit circle. It's asking me where the what is 1. What question do I need to answer? Where is what 1? The y. This is the y value. So where is the only place on this unit circle that the y value is 1? 5/2. And there are your answers. Just put them in. You'll separate with commas. It'd be there's 20 problems. I haven't added to it. There'd be some tough ones in there. This, for the most part, gets you going. Listen, won't be here Wednesday, but I'll finish the lesson for my even classes on Thursday. You can get it. Next week is the chapter 5 test. The week after that's the final. You have the whole week to do it. Okay, we're done. We come back, while we're doing, I'll do some other stuff with you, but it won't count to your grade. We'll stop there.